So we are talking about independent samples t-tests in this video. And it's specific to SPSS, but I want to do a quick reminder on what an independent samples t-test includes. So we talk about the nature and number of independent and dependent variables. And there are 3 different t-tests. We are doing an independent samples t-test in this video, and then the next video shows a paired or dependent samples t-test. And what we're talking about here is we have one independent variable with 2 independent groups or levels. And then our dependent variable, there's only one, and it is interval or ratio. And that's an independent samples t-test. So again, when we look for our nature and number of independent and dependent variables, a t-test that is independent is appropriate when you have one categorical and dichotomous independent variable, meaning it just has 2 levels. So if you were comparing people who love sports and people who don't love sports, those are 2 levels of an independent categorical variable. And the reason that they're independent is that there's not a relationship between the scores between those. So we don't have people who hate sports or don't like sports are not related to the people who do like sports, and you can only be in one group. So you're not going to be in both groups. So if you have people, the same people in group 1 and the same people in group 2, that is not independent. So we're looking at independent groups. And then the other part of this is that it needs to be a continuous dependent variable. And so it will be interval or ratio level of measurement. So I'm going to go ahead and go into SPSS and demonstrate this. So I am in the same example that I was in for the previous video. And you can see here that we have our variables. We have gender, we have age, we have yes, no, Hispanic. We have positive total, negative total, and satisfaction with life. Now, when we look at these, we're looking for what is appropriate. What would be appropriate for doing an independent samples t-test? And there's only one categorical variable that we could use as our independent variable. And remember that independent variables can be non-manipulated. So obviously Hispanic, we would not be able to manipulate somebody's identification as Hispanic, Latinx, or Spanish origin. So here we have a yes, no. We have a dichotomous categorical variable. So it's categories, and there's only 2 of them. So it's dichotomous. You can't see me, but I'm holding up 2 fingers. So this would be an appropriate independent variable. And then for the second part of our plan here for an independent samples t-test, we need a dependent variable that is continuous. So I cannot look at Hispanic origin by gender. That would not work. That is not a t-test. I could look at Hispanic origin by age, but that's kind of boring. So let's look at one of these other variables. So let's go ahead and do positive affect total. So we're going to compare people's positive affect total. We're going to compare their mean. This is a test of means. So we're going to compare the mean of positive affect for people who identified yes, Hispanic, and people who identified no, Hispanic. So I'm going to go to analyze, and I'm going to say compare means, because that's what we're doing. We're comparing means of the positive affect variable by Hispanic. So we're going to go to independent samples t-test. And when you go to that, again, it's always going to go, it's going to default to the labels. So I'm going to right click. I'm going to display my variable names. You could decide to sort by measurement level again. But we want to choose a test variable. That's our dependent variable. So it's going to be what we're testing. And then we're going to group it by our grouping variable. So our grouping variable, think of groups, categories. Our grouping variable is Hispanic. So we're going to move that to grouping. Now, this is the part that's a little weird, is that you need to define your groups. So even if we did have it labeled as 1 and 2, you would just need to go in and say continue. However, our groups are not 1 and 2. Our groups are 0 and 1. And those are just the values that we assigned. So you want to look at your code book and identify that. So it's whatever you have them assigned as in SPSS. We happen to have ours as 0 and 1. I'm going to say continue. So now you can see that we have our grouping variable. we are going to go ahead and choose our positive affect total as our test variable. We could do actually all of these at the same time if we wanted to, but I'm going to go ahead and leave it here. I do want to estimate effect sizes. And then we could look at options. We're going to leave this. We could change our confidence interval, but we're not going to worry about that. So I'm going to say, okay. And again, this is in the same output that I've been working on, but you can see our results here. So here, all right, I was trying to make this bigger, but you can see here. So we're looking at this t-test right here. So here is our syntax. So again, I can right click this and I can copy it and I could paste this into our syntax and I can learn from it and use it in the future. You can see that, again, not creative with the names, which is awesome. So t-test is our command and we're identifying our groups as Hispanic. That's our grouping variable. And so we've identified that we have a level 0 and a level 1. We're saying that we're going to exclude missing variables from analysis or missing responses from analysis. And then we're going to have our variable of interest, that is our dependent variable. We're going to do our positive total. So that's the variable name, our variable equals positive total. I could add another one. I could add neg total and rerun this. I'm not going to right now. And then we are going to, we wanted the effect size, which is Cohen's D in this case. So we wanted the effect size. So we say effect size ES and then display, and then true just means yes, we want to display the effect size. And then the criteria for our confidence interval is 0.95. So we are going to talk more about confidence intervals later, but 0.95 is the standard. So this is just something that we include in the analysis. So let's interpret this. We can see here that this is the row for no, not of Hispanic, Latinx, or Spanish origin. We had 3 people who identified as no. Our mean for positive affect was 22.67. Our standard deviation was 0.58, and our standard error of the mean was 0.33. So that's not very many people. This is a really small sample. We also have people who identified yes as Hispanic, Latinx, or Spanish origin. And we had 6 people in that group. And their positive affect total was, their mean was 14.5, and their standard deviation was 4.76. And the standard error of the mean was 1.95. So we have a lot more variation in the responses for people who identified as Hispanic. But again, these are very, very small samples. So the independent samples t-test gives us new information. This is just descriptive, right? This is just group statistics. We are just saying this is what we have in our sample. So what we're actually trying to look at is we are trying to evaluate, does our sample indicate that there's a difference between those 2 groups and that represents a real difference in the population? Can we make an inference to the population that positive affect is higher for people who are not of Hispanic, Latinx, or Spanish origin? So here is our independent samples t-test. We look at equal variance as assumed. This is talking about Levine's test for equality of variances. We're talking about variance with between our groups or within our groups. So we look here for this significance, and you can see that it's 0.40. Because it is less than 0.05, that actually means that we cannot assume equal variance. And so we're going to actually use this line, this equal variance is not assumed, and it gives us different numbers. So here we can see that the t value, because this is a t-test, we're calculating a t value on our t distribution, is 4.14. The degrees of freedom here is calculated differently because we're using this equal variance is not assumed, and it's 5.29. And our significance, our two-tailed significance, is 0.008. And this only calculated a two-tailed significance. You can also do this for one-tailed, but for the purpose of demonstrating this, I will stick with this example. So now we have information on our mean difference. That's a really big difference right here. And so this is a very small sample. I'm actually quite surprised that this is a significant difference, but we do have a significant difference here. We can see that both of these values are actually less than 0.05. And so we would say that this indicates that there's some difference in the population, or that there's not nothing, that there's not no difference. There's that null hypothesis test that we're rejecting. We're rejecting the null hypothesis. We're saying that we don't think there's nothing, right? So with this, you really want to think beyond just the significance to, could this sample of 9 people really be a good indication of what's happening in a population? 9 is pretty small, but it is a really big difference. So that's why the size of the difference and then your sample size, those are the 2 factors that really play into your significance level. So here is your samples, your independent samples t-test that we just conducted. You also have a 95% confidence interval. And so this gives you a lower and upper limit around your mean value, your mean difference. And so here we now have our independent samples effect sizes. And this last little bit of information, you can see our Cohen's d. Our point estimate is 2.02. That is big. That means that between our 2 means, there is a difference of 2 standard deviations. So that is the analysis for an independent samples t-test in a nutshell for SPSS. And again, you can modify things about your t-test and your syntax, but this is what it will look like when you do a standard analysis. So I would definitely recommend playing around with it. Take things out and see what happens. Change it around. So for example, we could do them together. I don't know why I keep putting B for N, but neg total. We could run this again, and it does both of them. You could decide that instead of ES true, we're going to say false. And we no longer have effect size. So this part here, that's what that ES was. So don't be afraid to get in there and play around with your syntax and see what happens when you change things, because that's a really good way to get comfortable with it. So our next example, I'm going to do a dependent samples t-test. And that is the end of this video.